You think is a good thing to, just let the computer do and learn, even though we don't understand how it's working?
You can make good things with neural networks as well as you can do harm.
What's your career journey, briefly? I see that you work as an engineer before, and now you're a professor.
Okay, so I studied mathematics with minor subject physics, and I did my PhD in what we call computer science, so about the solution of partial differential equations, numerical solution. And this involved me more into the numerics and the computer technologies and software development. And then I started to work, and I was at my last position, I was at BMW, working with BMW in a think tank about automatic code generation. This was the first part, and the second part was about the whole vehicle simulation aspect. So for the development, I don't know if you know the V-cycle, very famous development paradigm, the V-cycle. And the more you can do up in the left to see if your product idea will in the end fulfill the requirements, the more you need simulation, the better it is for the development of the product. And this was really interesting, and we come up with a development simulation environment for the whole vehicle, which was really interesting for at that time, 2010, about the vehicle dynamics. And then more and more others and topics came into the field. And then in 2012, 2013, there was a big need indicated by industries for others engineers. And the Bavarian state said, okay, we will support this. And then I was first as a sponsored professor from Continental, a big supplier in Germany for automotive industry. And we started in 2014 with the master course of advanced driver assistance systems, which was unique at that time. And so this is basically the idea, and I'm building up this master course, and now over 250 students have passed it, and they're in all the world working. And in the meantime, I got also visiting professor of the Shibao Institute of Technologies in Tokyo, Japan. So it's really amazing. No day is like the other day. It's always interesting stuff to do. So, and tomorrow I had a call in the Far East with Japan.
It looks like you really enjoy your life as being a professor. What do you think is the biggest difference on working in the industry for BMW and being a professor right now, which might be focused more on research and teaching? The difference, do you have a preference? Do you enjoy one more?
If you are working with a big company like BMW, the products push you to the front end of the research because you need better solutions, you need faster solutions, you need more efficient solutions. So there's a lot of money available for specific topics that arrive from the product development. So, but the focus is on implementation, okay? So as a professor, you are not so much interested in the implementation aspects, but more in setting points that make research valuable. So that later on you can implement on that. So this is the difference. In the industry, research is driven by product development and implementations aspects are important. As a professor, you can set topics that need not really to be implemented. Of course, it's good if you find a topic that in later is then implemented and it shows that it's a good idea from you, but you are looking more for ingenious ideas. So, and both of them has their interest, pros. It's very interesting to do both of them, but both of them have their cons. And for me personally, this professorship is the right thing. So I like it. And my focus is on simulation. I combine my deep mathematics stuff with my experience from BMW for the simulation aspects, and so I like very much.
I see. Yeah, it looks like, because for me, myself, I have previous thought about, should I continue doing a PhD or should I get into the industry? For me, I did my master in mechanical engineering, and now I'm working in a company called Ecotron. They do controllers for electric vehicles and autonomous vehicles. But I have that. I went to the crossroad on whether I should go to research or industry. But I think I'm more interested in the industry, which, you apply your knowledge and actually work on, more realistic stuff. But I think both research is also really important in supporting the growth of the industry.
The both things are interesting. And if you look in the history of the great things that are developed or found, then you always found a specific problem that had to be solved. For example, the Gaussian algorithm to solve linear equations. Maybe you know about that from mechanical engineering. And if you go in the history, you will find that the point where Gauss found this algorithm was an astronomical problem. They saw a special moon from the planet. Then it was lost, and everyone wanted to know where is it appearing again. And then Gauss took this approximation algorithm, and with that he found these solving equations or solving of linear equations. So typically it's always the edge of front-end development and research for a real need for a product that people uses.
I definitely agree with that. I think the breakthrough research is constantly supporting the breakthrough of the industry as well. And the industry, as they develop the product, they have more needs. They might need research to support that. They're really interrelated.
Yes.
Yeah. And talking about your field of research and simulation. So are you talking about like simulation of like the roads and vehicles on, to train autonomous vehicles? Is that what you're mentioning about?
Yes, if you go in details, if you start and look at the system, then the first level of the system has three components. It's the driver, and that's the vehicle, and that's the environment. And they are interconnected. And of course, for others functions, the driver is still in the loop, but it's replaced by algorithms later on towards AD applications. And if you look in the interaction chain, it's always sense, plan, act. So you have to sense the environment. So then you have to decide what is your plan. Is there something that makes your plan not feasible? Then you have to act, and here is steering and braking or accelerating possible. And then every 20 milliseconds, 40 milliseconds, you go again in this engineering closed loop cycle and look what's up new. So this simulation is very challenging, because if you look at the vehicle is well understood, because you have several 10,000 signals on a bus in a vehicle that give you the state of the vehicle. So about the engine, about the driving, about the sensors, and so forth. The will or the abstraction of the driver is also quite easy. You indicate the light, the turn, the indication. If you go left or right, you accelerate with the pedals or you brake with the pedals, and you have your navigation system. But the environment is the challenge. It's unforeseeable what can happen in the environment. No one in Earth can tell what a vehicle is focused. And this is really challenging. And I think it is a mankind problem to understand what can happen around us. And this is not solved by a single company, not by a single automotive problem. All the mankind has to contribute in that. And the first step is to come up with a standard. What is perceivable outside a vehicle? Then we can pool all these efforts together. There are people who have more strong in understanding vehicle, other are doing human-machine interaction. The next one is understanding what is happening in a city. The next one is understanding what is happening on a motorway. And if we can pool all this knowledge together by a standard, we can get much faster to solve this topic of autonomous driving than everyone else can do that. And this is why I am a fan of simulation. And there's a standard, it's from the ASAM, it's Open Simulation Interface, and it's worth to look inside that.
I see. So when you mentioned about the environment on, is that like how much a car could perceive the environment? Is that what you're mentioning about?
Yes.
Okay, how do you think we could improve on that? Like, is it about adding more sensors? Is it about the algorithm of sensor fusions? How can we get better at that?
So if you look at the physical point, so there are only information can be brought from one point to the other point in space by electrical waves or by mechanical waves. So for the electrical waves, you have LiDAR, you have radar, and you have camera. And for the mechanical waves, you have ultrasonic. So I think there is not much to improve on the types of sensors. I think this is quite good. And you have, of course, the map as a virtual sensor, because the detection is done ahead, maybe years ahead. Then you come up with a map and you just bring in the objects in a list that you can access to it in runtime that you need it. For the other sensors, for the real sensors, you always detect the environment in real time, and this makes it so hard to process. And the fusion is, of course, very important. The sensor fusion, I think this is a topic that is to deal with. And I think that we should more understand how our brain works. So our eyes and our ears and our nose and our smell, and how our brain does this fusion, because it's really amazing. If you look in the detail and discuss with physicists about that, it's amazing what nature has for mechanisms and methods to detect outside. And also we learn that our brain also has not the focus on make a realistic image of the environment, but a useful image of the environment. You know, all these illusions and so on that we underlie. And this is because we are mammals, we are animals that has to survive in this environment. And if we look more in these details, we can understand, I think, and learn a lot of how a car could better perceive the environment.
I see, yeah. I think the ultimate goal of AI or like machine learning is to, be like human, to be, I think they call it biotonic, to actually, it's really interesting. And, knowing how the brain works would definitely help AI developing and for autonomous driving as well.
Understand the pros of our perception and understand the impairments of and do not bring these impairments to the computers, but improve it. So I think there is a big chance. And this is only the perception. And the other interesting thing is the plan. How shall we, if suppose that we could have 100% correct picture of the environment, then still we need to understand how to decide what to do. So, and this is also really interesting if you look in the performances of computers. So, Czech was beat, the human Czech players was beat maybe 20 years ago, 30 years ago, the Kasparov, I think 1995 or something like that. And I don't know if you're familiar with the East Asian chess, so one can say. And I think Lee Sedol, the Korean guy, who was the world's best Go player in 2016, was beaten by a program from AlphaGo. And now the really interesting thing was the team of AlphaGo did not understand how the program was moving. But later, backwards, posterior, they could understand why it was a good thing to do that. And it was because it invented a strategy that no human player had before. And this is amazing. So this is why I believe in machine learning and neural networks, that they will find solutions that our brains, all our brain knowledge together of all humans, we are somehow blind because we are animals, kind of animals, and we are blind on specific spots. And now hold on, the very most important topic is that now the Go players adapt this strategy and can beat again AlphaGo. So, and this is amazing. Do you understand what we have here in our head is amazing. So it's really great. Even the machines, if we copy and learn all our knowledge, we still are able to beat the machines back. So this is really, and this we need to bring also to the autonomous driving. So
yeah, I think that's something in autonomous driving where like Tesla, but basically they are kind of doing like end-to-end, which is like a black box. Like sometimes even the engineers, researchers, they don't know what is going on, but they just let the car learn and know how to drive. And, that's definitely, and the performance shows that, it's doing way better than, previously programming it. And at the same time, I think some people are actually afraid of that. Of like, okay, I'm not sure what does the computer think, So what are your thoughts about that, Do you think is a good thing to, just let the computer do and learn, even though we don't understand how it's working?
So my point of view on that topic is that all those people who rely on mechanical engines or machines like they are available today, all these machines, basically rely on Newton's law and Euclidean geometry. So if you combine that, more or less you can describe all machines, even the rockets, they go to the moon. So, but we got used to that Euclidean geometry 2000 years and Newton's law over 300 years, and we get used to it. Now we believe them. But if you look on these equations on Newton's law, there is, for example, the describing points is time, mass, and no one can explain what is time and what is space. So no one can give you the entity, the purpose of that, or why it is in place. And now if you go to machine learning or to neural networks, no one knows at the moment what these nodes in a neural network mean, what they are, what is their semantics. But everyone is scared about that because we need to get used to this kind of tool. And I'm sure in 300 years, no one will pose this question because everyone gets used to it and it's working. And of course, this is with all our machines also. You can take a knife to make a good, to cut the bread for the breakfast, but you can also take a knife to make harm. So it's not the tool that is bad, it's the people who use these tools. They make the difference of good and bad. So this is my 2 cents to this discussion.
Yeah, that's a good way to put it. Yeah, it's definitely, there's a tool, and the intention and who is using it, I think is probably more important than what the tool could actually do. Cool. Yeah, I think that's some really interesting thoughts. I also have like a question for more like, I think usually younger people will have this question, and this is a question for you. What advice would you give for your 20-year-old self?
So my advice to you is always do that what you are burning for. So the world is so big and there's so many interesting things to do, and you will always find a place with your knowledge, with your interests to do that. So don't get too much driven by thoughts like, what will I be in 20 years? Where will I have my money in 50 years? No, do what you like and burn for it, and you will see you will have success on that. This is my advice to you, and you are the future, so please.
Yeah, it's really nice talking to you.
Yeah, I enjoyed it very much. Thank you for the interview.
Thank you. Have a good day.
Bye.
Bye-bye.